What if I told you that a huge chunk of higher math, we're talking graphing, algebra, even calculus, is all built on one single, really simple rule? It's a rule that you already get intuitively, and once you see it, you're going to start seeing it everywhere.
So let's just imagine for a second. You go to work, you put in your hours, but when payday comes, the amount you get paid is a total guess. One week you work 30 hours and you get a decent check. The next week, you work the exact same 30 hours and your boss just pays you less. It'd be chaos, right? You just can't depend on that.
Now, a dependable job or reliable system, that looks a lot more like this. For a specific input, the hours you worked, you get a specific output, the pay you receive. And notice here, it's totally okay that working 30 hours and working 40 hours can lead to the same $490 output. Maybe it's just two different people with different pay rates. That's fine. The relationship is still predictable.
But this right here is a problem, a big one. The same exact input, 30 hours, is now leading to two completely different outputs, $490 one time and $310 another. It's not dependable. You can't rely on it. And this exact kind of problem is what mathematics absolutely had to solve.
And that brings us to the fundamental rule that makes math predictable. It's the core idea behind something we call a function.
So, what is a function? Well, it's really just a fancy name for that dependable relationship we all want. It's a rule that says for any one input you give it, you will get back exactly one output. No surprises, no randomness, just consistency.
And that's it. That's the golden rule, the whole thing in a nutshell. One input goes in, one and only one output comes out every single time. But here is the one condition that can never, ever be broken. While it's okay for different inputs to give you the same output, like our two workers earning the same pay, a single input can never give you more than one output. That is the heart of the rule.
And in math, we've got special names for these things. The input, like the hours you work, that's called the independent variable. It's what you choose to put in. The output, your paycheck, that's the dependent variable, because what you get out depends on what you put in. Makes sense, right? You pick an x, and the function gives you back a y.
Okay, so now that we know the rule, how do we actually spot when it's being broken? Let's go ahead and become function detectives for a minute.
All right, take a look at this set of points here. Our inputs are -2, 1, 0, and then 1 again. Okay, so the input 1 is repeated, but hang on. Both times it points to the exact same output, 4. There's no conflict. So this is a perfectly valid function. It follows the rule.
Now let's look at this set. The inputs are -2, 3, 5, and, -2 again. See the problem? The first time, our input -2 gives us an output of 5. The second time, that same exact input gives us a 6. That's the broken promise right there. One input, two different outputs. This is not a function.
So that's pretty easy to spot in a list of numbers. But what about in an algebraic equation? Well, turns out the culprit is usually hiding in plain sight. The strategy is always the same. Your one goal is to get the output, that dependent variable y, all by itself on one side of the equal sign. You want to isolate it and see what you're left with.
So let's try it with this equation right here. We want to get y alone. First step, let's move that 2x squared over to the other side. Okay, now we divide both sides by 3. So now we have y squared. To get to just y, we have to take the square root of both sides. And it's right at this moment that the problem shows up. As the fantastic Professor Leonard puts it in his lecture, the second you have to write down that plus or minus symbol to solve for y, that's your red flag.
That little plus or minus symbol is basically the mathematical version of our unpredictable paycheck. It's a little instruction that says, for the one x value you just plugged in, you now have to create two different y values, a positive version and a negative one. And that just shatters our fundamental rule.
So here's the ultimate cheat sheet for you. An equation like y = x squared, that's a function. Any x you put in gets squared and you get one y back. Simple. But an equation like y squared = x, that's not a function. Because to get y by itself, you're forced to take a square root, which means you have to add that plus or minus, and it fails the test. So the main thing to watch out for is that sneaky y squared.
So why do we care so much about this one simple rule? I mean, why is it so important that it's basically the foundation for so much of modern math?
It all comes down to predictability.
Functions give us predictable, dependable relationships. When you ask your GPS, where am I going to be in 10 minutes, you need one single, reliable answer, not two. And that's a function working behind the scenes. This ability to model one outcome for one input is what lets us predict everything from a rocket's path to how an investment will grow. Without this rule, math would just be chaos.
So let's just quickly wrap up what we've covered. The key takeaways are simple. A function is just a rule. One input gives you exactly one output. That means an input can never have more than one result. When you're looking at equations, keep an eye out for y squared. It's the usual suspect that creates that rule-breaking plus or minus situation. And remember, this whole idea of dependability is what makes all of graphing and calculus possible in the first place.
It's interesting, isn't it? Functions bring this rule of absolute predictability into the abstract world of math. And that kind of makes me wonder, what are the simple, unbreakable rules that you use to bring predictability and order to your own world? Something to think about. Thanks for tuning in.